In the remainder of the lectures that we're going to be giving in this course, we're going to focus primarily on what could be called a biological approach to cognitive science. We're still going to be looking at the ways in which machines and computers can model the behaviors of intelligent behavior. But we're going to look at that through the lens of things like evolution, animal behavior. We'll probably spend a little time on children's cognition. In other words, topics that are sort of linked in one way or another to biological development and to biology in general. And by way of transition to that, we've been talking about game theory. So I wanted to introduce, or at least mention, a few of the ways in which game theory has influenced or overlapped the study of evolution over the last 30 or 40 years. So we'll be talking about a couple of ways in which we can gain some understanding into those aspects of cognition that are influenced by evolution. Perhaps we could say that all aspects of cognition are influenced by evolution. But what we're going to talk about is how certain particular phenomena in evolutionary cognition, evolutionary cognitive psychology, can be illuminated by game theory. The landmark book in this area came out actually about 50 years ago, something like 50 years ago. It was by the biologist Richard Dawkins. Maybe it was more like 40 years ago. In any event, it was called The Selfish Gene. Came out in like the late 70s or early 80s. And the book is really a remarkable book. It's a very provocative book, and it's beautifully written. The arguments in it are exceptionally interesting, fascinating. You may not agree with all of them, and in fact, in the years since the book has been published, there's been a lot of back and forth on particular issues raised by the book, and it's safe to say that there are many people who disagree with many of the points made in the book. However, the reason that a book like this is a landmark is not because it gets all the right answers. It's because it asks interesting questions. And The Selfish Gene really does ask very interesting questions and gives the reader a remarkably different way of looking at biology and life in general. Now, the title of The Selfish Gene is capable of being misunderstood. The idea is that Dawkins says we can look at evolution not from the standpoint we're used to looking at it, which is from the standpoint of the living animal, but look at it from the point of view of the gene. The purpose, if you can call it that, I mean, it's a bit of anthropomorphism, but there's some justification to it. You could say that the purpose of the genes is to reproduce themselves. The purpose of the genes is to keep going. That's their purpose. And by looking at evolution and animal and human behavior, as well as other organisms, by looking at evolution through the lens of the gene, one can argue that many phenomena take on a different cast when you view them as promoting the immortality of the genes. We are not immortal. Animals are not immortal. But genes strive to be. They want to copy themselves and they want to keep going. Indeed, some genes in the human line are very, very old indeed, much, much, much older than human beings, much older than the order of mammals. So looking at it from that point of view, one can say that the genes are being selfish. The genes are ordering ordering around the animals which carry them in order to perpetuate themselves. The gene, therefore, is selfish. That does not mean that the animals carrying them need be selfish. This is not an argument that human beings are necessarily selfish animals. It does mean that their behavior can be analyzed not always through a determination of what the person wants, but what the person wants on behalf of the genes they are carrying. Dawkins used some provocative phrases in his book. I'm not sure I'm getting this verbatim, but he described human beings, among other animals, as lumbering robots carrying around their genes and sort of making decisions that every now and then they think are on their own behalf, but are really on their genes' behalf. This gives, I've listed a few sort of phenomena that one can think about when one starts viewing biology from the gene's eye view. We could start with the bottom bullet there, death. You could ask, well, if the genes want to be immortal, why don't they make their carriers immortal? Why do we have to age and die? That seems to be something kind of built into our genes. Now, you could argue, and maybe it's possible to argue, that the biological structure of genes themselves precludes an exceptionally long lifetime or immortality. But then again, there are animals that live a good deal longer than us, Galapagos tortoises for one. Why can't we live to 150, 180? If the genes want to be immortal, or at the very least as long-lived as they can be, why don't they make us long-lived or longer-lived? One way of thinking about this from the selfish gene point of view is that the genes don't really care about whether any one particular carrier lives exceptionally long or forever. They're not after that. They're after the perpetuation of themselves. In other words, and again, I'm playing fast and loose with the language here, but informally one could say, if the animals carrying the genes then reproduce and copies of the genes are delivered over to the next younger generation, the genes are happy. And they don't really need us to hang around anymore, the older generation to hang around anymore. In other words, it's kind of like, again, to play a little fast and loose with the language, it's kind of like trading in a car as far as the genes are concerned. They don't want to invest in keeping us healthy and long-lived for exceptional periods of time. That may be a risky thing to do. After all, accidents happen. A piano could fall on our head. The genes don't really want to, they want to recopy themselves into younger, fitter, less injured, less worn down bodies, just the way that you might want to trade in a car. So it's not in the genes' interest to make us immortal. In fact, it's rather in their interest in the longer term to allow us to wear out and die, as long as, in the main, they get to perpetuate themselves by reproduction into the next generation. A related question has to do with sexual reproduction. What's the advantage in sexual reproduction for genes? Not every animal reproduces sexually. We could just kind of spawn off clones like an amoeba does. Wouldn't that be just as good from the gene standpoint in terms of perpetuating their existence? The idea here and the argument, and this is, again, this is something of a game theoretic argument that Dawkins is making, is that for animals like ourselves, we don't, for animals in general, we don't just have one, it's not just a question of reproducing one gene. We have a collection of genes. In our case, thousands of genes. Something on the order of 10,000 distinct genes. There are arguments about that, but let's just say something on the order of 10,000 distinct genes. From the gene's point of view, they're trying to survive and to reproduce and to sustain themselves in the company of 10,000 others like them. That is, they're on a team. They're on a team of 10,000 other genes. That may not be the best team to be on. The idea of sexual reproduction is that genes can mix up their teammates somewhat. Instead of just cloning the exact same team over and over again, which again may be risky from the evolutionary standpoint, particularly for complex animals, there may be problems with one particular team of genes that would preclude reproduction as the generations go on. So in other words, from the gene standpoint, they're kind of thinking, and again, I'm anthropomorphizing, they're kind of thinking, well, I should mix it up with some new teammates every now and then. And you know, that cuts my losses, or at least it makes it a better bet that I'll be able to survive under environmental changes into the new generations. So sex is a good idea from the gene standpoint, sexual reproduction. It means that they're not always with the same set of teammates among genes. Those are, you know, game theoretic explanations from the gene standpoint of rather large-scale phenomena like death and sex. There are other sort of more fine-grained phenomena. Let's talk about the first two bullets here, altruism and kin preference, because that gives a particularly sort of good, specific, solid example of how you can reason from the gene's eye perspective, how you can reason in a game theoretic way to explain certain kinds of animal behavior. So I'm going to tell you a story. This is, well, first I'm going to show you a picture. This is a ground squirrel giving an alarm call. And this has to do with the subject of altruism. Now, altruism is in the classical evolutionary literature, altruism is something of a difficult phenomenon to explain. It at least demands an explanation. Altruism meaning taking a personal risk, maybe a very significant risk, in order to help others with no apparent benefit to oneself. Okay? We know of altruistic behavior in humans. People do, you know, take great pains sometimes to help others without any anticipation necessarily of reward. Sometimes they sacrifice themselves for others. From the classic evolutionary standpoint, that's a bit of a puzzle. The idea is, why should an animal, which is after all, you know, concerned with itself and concerned with perpetuating its genes, why should an animal make sacrifices without any apparent gain on the behalf of another animal? This particular case is an interesting one. I'm going to start by telling you a story where I saw this phenomenon, or something very like it. This was up in Snowmass, Colorado, and I'm going to have to use my hands here to explain what was going on. My wife and I were up in Snowmass with our first dog. He was a great dog. He was a terrier. And I have to admit, he was not necessarily the brightest dog in the world. He was the sweetest dog in the world, but maybe not the brightest. Anyway, she disagrees. My wife disagrees, but that's a whole nother story. There we were outside in a kind of a yard or field, and my dog was looking this way, sort of had his nose pointed off this way, just taking in the scenery and enjoying it. Up behind him, I guess I should put these down. Up behind him came a chipmunk from a hole in the ground who happened to be looking the other way. So the two animals were just looking in opposite directions. It was almost like a Warner Brothers cartoon. I'm just standing there looking at this like, one of you is going to notice the other pretty soon. So they're both looking, in opposite directions. The chipmunk turns and sees my dog, and I have never seen a double take on the face of an animal like I saw in that chipmunk. The chipmunk was just sort of looking in a lazy way out this way, turns around, sees the dog just a couple of feet from it, and the chipmunk's eyes went nuts, and the chipmunk screamed, and then my dog turned around, saw the chipmunk, dove for it, but the chipmunk got down his hole in time. So no harm, no foul. Everybody was okay. Now the interesting question here, the question from the standpoint of altruism, is why scream? I mean, why not? I could have told the story, it didn't happen this way, but I could have told the story that the chipmunk came up, they were looking in opposite directions, the chipmunk turns around, sees my dog, and then just dives back down into his hole. And the dog would never have never have been any the wiser, would never have turned around and jumped after the chipmunk. That wouldn't have happened. In other words, a safer choice for the chipmunk would have been not to scream at all and simply dive down his hole and have done with it. Many ground rodents don't do that. The chipmunk, this ground squirrel here, they don't do that. They scream. And the way that's usually interpreted is that they're making an alarm call. They're not just behaving for themselves, they're alarming giving an alert to other chipmunks or squirrels in the neighborhood that there's some danger here. Better get down into your holes if you want to be safe. They take a risk in making that alert. That is, the screaming, that could have cost the chipmunk its life. My dog turned around and jumped after him. Sometimes a scene like that ends badly for the chipmunk. In this case, the chipmunk got away, but they don't always get away. So there is an aspect of true altruism about this. The squirrel or chipmunk is making a scream that helps others, but puts itself at risk. Now, why, from the evolutionary standpoint, why would an animal do that? Why not just save its own skin? The selfish gene explanation says the point here is not to, the behavior is not purely altruistic. It is not to say, to save. Some people used to make an argument that, oh, the squirrel is doing this on behalf of the species. Well, that's kind of odd. I mean, does the squirrel even have a notion of the species, and what does it care about the species? A better explanation is that if there is a genetic component, there are genes, a gene or a small collection of genes that promote this behavior in squirrels or chipmunks. The point of making this behavior is not to save their carrier, it's to save the copies of themselves that may be sitting around in other related chipmunks or squirrels. In other words, the genes are saying, again with some anthropomorphism, they're saying, look, the guy that's carrying me we're willing to sacrifice as long as the copies of ourselves in his brothers and cousins and sisters and so forth, as long as those copies are made safer, and enough of them are made safer on average, we do better. We genes do better by sacrificing this particular guy who's carrying us if we can save enough copies of ourselves in his nearest kin. I can't remember who this was, but there was a famous biologist who was once asked if he would dive into a raging river to save his brother. And he said, again, I'm not positive about whether this is verbatim, but he said something like, no, I wouldn't dive in to save a brother, but I would dive in to save 2 brothers or 8 first cousins. Meaning that your brothers, on average, share half their genetic component with you. If you can save 2 brothers by sacrificing yourself, then on average, it's an even break as far as the genes are concerned. You're on average saving a copy of just about every gene. Your first cousins are 1/8 related to you. That is, they share 1/8 of your genome. So if you save 8 or more first cousins, that's a good bargain for the genes, even at the cost of yourself. Similar thing is going on here. Now, this is an empirical question. There is a question of, for example, are squirrels or chipmunks more likely to give an alarm call when they know that close relatives are in the neighborhood? That's an empirical question. But this is a reasonable explanation for why a chipmunk might do something like this, might make this kind of altruistic behavior. It's not on behalf of the species, it's a gene behavior, not a squirrel behavior. It's a gene behavior saving copies of itself, not a squirrel behavior sacrificing itself for the good of other squirrels. There are other animals which also illustrate, this same kind of gene-based judgment. This is an African bee eater. It's a specific kind of bird, very pretty bird. The story that, by the way, many of the instances that I'm relating here are from a wonderful book by an author named, the last name is Gadagkar, Gadagkar, called Survival Strategies. And it's about applications of game theory to animal behavior, and there are many of them. So this is an African bee eater. Now, for this particular bird, usually when birds are raising their eggs, they build a nest, they hatch their eggs, and then for a certain amount of time, they raise the chicks in the nest until the chicks leave the nest, okay? And usually that involves just the parent birds, the mother and the father bird, okay? In the case of the African bee eater, it turns out that in many, many cases, I don't think in all cases, in many cases, there are 3 adult birds in the nest, not 2. There's the mother, the father, and what's called a helper bird. The helper seems to help the parents feed the nestlings. It goes out and gets food or does chores or whatever, and it helps the parents raise their kids. Now again, this seems like altruistic behavior. Why would a bird do that? I mean, of what interest is it to a bird, a bee eater, to help 2 other birds raise their chicks? Seems like a lot of effort for not much genetic reward. There are different kinds of hypotheses that biologists investigated. They thought, okay, we can think of this game theoretically. Maybe it's a trade-off. Maybe a bird that's a helper bird this year will be helped by one of the parents next year, a kind of tit-for-tat situation. Turns out not to be that. They thought, well, or maybe it's a younger bird that is, doing this to be an apprentice, a sort of apprentice parenting, so it'll learn something about parenting. It's not that either. What's the reason that the bee eater does this? Turns out it's an uncle or an aunt. That is, the helper bird is the brother or sister of one of the parents. And they share, on average, 1/4 of their genetic component with the nestlings. So again, assuming that there can be enough successful nestlings brought to adulthood by this kind of helper behavior, it might certainly be in the interest of the helper bird to assist with raising the chicks. These are nephews and nieces. So there's a 1/4 genetic component. They're not quite as close as children, but they're more close than, a lot more close than a total stranger. So this is an example of how kin selection might work. And again, it might work on the basis of what one could describe as, the tenets of the selfish gene.